Hey everyone, welcome back to Simple Learning AI. Last time, we explored neural networks. Today, we're going deeper into deep learning. What is it? Why is it so powerful? And how does it work behind the scenes? Let's find out. What is deep learning? Deep learning is a specialized branch of machine learning that uses neural networks with many layers. That's why we call them deep. Think of each layer as a stage where the data gets transformed. The first layer might detect lines and edges in an image. The second layer might find shapes like circles or squares. Later layers identify full objects like faces or cars. Just like our brain uses layers of neurons to process information, deep learning mimics this, and that's what makes it so powerful. How it works. Deep learning models learn features automatically. You don't have to manually define what the computer should look for. It learns by itself, from data. It goes through a process called forward propagation, where the input moves through all the layers. Then backpropagation adjusts the model when it's wrong, kind of like self-correction. Let's walk through how this works, layer by layer. Input layer. This is where the data enters the neural network. Hidden layers. These are the heart of deep learning, and where the magic happens. Each hidden layer is made up of neurons, and each neuron does a simple job, takes input, applies some math, a weighted sum, passes the result through an activation function to add nonlinearity. Weights and biases. Each connection between neurons has a weight and a bias. At first, these values are random, the model has no clue. But through training, the network adjusts these values to reduce errors. Activation functions. These are formulas that decide whether a neuron should fire or stay quiet. Common ones include. We talked about types of activation function in previous video. If you don't know about it, just watch that video. Scores. How do we measure deep learning performance? Once your deep learning model is trained, you need to evaluate how well it's doing. That's where scores and metrics come in. Like accuracy, precision, recall, and F1 score. These scores help you track your progress and decide if your AI is really working. Output layer. This is the final layer in a neural network. It presents the results, transforming the information from the hidden layers into a format that solves the task at hand, such as classification, regression, or any other type of prediction. How do we measure deep learning performance? Once your deep learning model is trained, you need to evaluate how well it's doing. That's where scores and metrics come in. Classification metrics. Accuracy. The percentage of correct predictions. If your model made 100 predictions and got 90 right, the accuracy is 90%. Precision. Out of all the times the model predicted positive, how many were actually correct? Of 6 emails marked as spam, if 3 really were spam, precision equals 50%. Recall. Out of all the actual positives, how many did the model catch? There are 3 spam emails, and your model catches 3. Recall equals 100%. F1 score. The balance between precision and recall. Useful when you need both high precision and high recall. It's the harmonic mean of the two. Confusion matrix creates a nxn matrix, where n is the number of classes or categories that are to be predicted. There are 4 terms you should keep in mind. True positives. It is the case where we predicted yes and the real output was also yes. True negatives. It is the case where we predicted no and the real output was also no. False positives. It is the case where we predicted yes but it was actually no. False negatives. It is the case where we predicted no but it was actually yes. We get accuracy, precision, recall and F1 score from confusion matrix. Regression evaluation metrics. Mean absolute error, MAE, is the average distance between predicted and original values. Basically, it gives how we have predicted from the actual output. Mean squared error, MSE, is similar to mean absolute error but the difference is it takes the square of the average of between predicted and original values. Root mean square error, RMSE, is a metric that can be obtained by just taking the square root of the MSE value. R2 score. The coefficient of determination, also called the R2 score, is used to evaluate the performance of a linear regression model. So why is deep learning so popular? Because it's great at solving complex problems like image and speech recognition, language translation, self-driving cars, generating art and music, even medical diagnosis. Deep learning has outperformed humans in some tasks, like detecting certain cancers in X-rays. If you enjoyed this, hit like, subscribe, and turn on the bell so you never miss a new AI video. We're just getting started with deep learning, and next, we'll dive into types of deep learning. Thanks for watching. Got questions? Drop them below. See you in the next one.